In the vast quiet of interstellar space, where light takes centuries to cross the void and silence is the only constant, something drifted through the dark. It had no name at first, only a designation, a catalogue number in the ledger of cosmic wanderers. 3I Atlas, the third interstellar visitor we had ever documented. It came from beyond the solar veil, from a place we could only imagine, and it left without ceremony, dissolving into the blackness from which it emerged. But space, we have learned, does not forget. Months after 3I Atlas vanished beyond the reach of our finest instruments, something unusual began to surface in the archives. Deep space radio telescopes, those patient sentinels of the electromagnetic spectrum, had captured faint irregularities, whispers buried beneath layers of cosmic static, patterns, repeating sequences, echoes that aligned with the object's final trajectory, as if the void itself had recorded its passage and was now playing it back. The signal came after the silence. Scientists worked quietly, cross-referencing data streams, filtering noise, searching for coherence in what should have been emptiness. What they found was neither a shout nor a declaration. It was something far more subtle, a resonance, a frequency that seemed to respond to the act of observation itself, as if the universe had been waiting for us to ask the right question. This is not a story about aliens or ancient technologies. It is a story about listening, about the space between data and meaning, about what happens when we discover that silence is not the absence of sound, but the canvas upon which all sound is painted. What if the silence was never empty? Chapter 1. The Night the Sky Whispered. It began on a Tuesday, in the early hours before dawn, when most of the world was still sleeping and the radio telescope stood alone beneath the stars. The observation logs would later show nothing unusual at first glance. The same torrents of cosmic microwave background, the same pulsar ticks, the same hiss of hydrogen clouds stretching across the spiral arms of distant galaxies. But buried within the noise, imperceptible to the automated filters that process terabytes of data every hour, was something faint, a ripple, a deviation so slight that it required a human eye, guided by intuition more than protocol, to notice it at all. Dr. Yuki Tanaka had been reviewing archived recordings from the Atacama Large Millimeter Array, not searching for anything in particular, but performing the kind of routine maintenance work that occupies the quiet hours of astronomical research. She was looking for calibration errors, instrumental drift, anything that might explain minor inconsistencies in recent observations of Sagittarius A. What she found instead was a harmonic pattern embedded in data captured 3 months prior, data that corresponded almost precisely with the final known trajectory of 3I Atlas. At first, she assumed it was interference, satellites perhaps, or a glitch in the correlator systems. But when she isolated the frequency and mapped it against the object's orbital path, the correlation was undeniable. The signal appeared to originate from the space 3I Atlas had occupied weeks after it should have been undetectable, long after it had faded from visual observation and dropped below the sensitivity thresholds of even our most powerful instruments. She ran the data through spectral analysis algorithms, expecting the pattern to dissolve into randomness. Instead, it sharpened. The frequency showed structure, repeating intervals, harmonic overtones, a rhythm that was neither mechanical nor natural in the way we understood natural phenomena. It was too regular to be stellar noise, too complex to be instrumental artifact. Yuki sat in the dim glow of her monitors, the only light in the observation chamber, and felt the weight of what she was seeing. In astronomy, silence is not emptiness. It is the baseline, the canvas against which every discovery is painted. We listen to the universe constantly, passing its electromagnetic voice for meaning, for pattern, for signs of anything beyond the expected choreography of physics. Most of what we hear is predictable. Stars burning, matter accreting, radiation diffusing across the cosmic web. But sometimes, rarely, the silence shivers, and when it does, we lean in closer. She forwarded the data to her colleague, Dr. Marcus Webb, with a single-line message. "Check the Atlas archive. Tell me I'm wrong." He wasn't able to. Within 48 hours, a small team had assembled quietly, away from the broader scientific community, to examine the recordings in detail. They cross-referenced data from multiple observatories, the Very Large Array in New Mexico, the Meerkat Telescope in South Africa, the FAST installation in China. Each showed the same faint signal, time-delayed according to distance and the speed of light. but unmistakably present. It was as if 3I Atlas had left behind not just a gravitational trace or a fading light curve, but something else, an acoustic shadow, a resonance lingering in the fabric of space itself. The team worked through the implications carefully, methodically, aware that every extraordinary claim in astronomy is met with extraordinary scrutiny. They ruled out solar interference, ruled out equipment malfunction, ruled out terrestrial sources. What remained was a signal, faint, structured, and impossible to explain by conventional astrophysics. It was Marcus who finally voiced what they were all thinking. "It's like an echo," he said quietly, staring at the waveform on the screen. "But echoes need something to bounce off, and out there's nothing." Yuki didn't respond immediately. She was watching the pattern repeat, the harmonic intervals rising and falling like breath. But this was not the first time the universe had spoken in delay. Chapter 2. The object that shouldn't have been to understand. What 3I Atlas was, we must first understand what it was not. It was not a comet, though its initial classification suggested otherwise. When the Asteroid Terrestrial Impact Last Alert System first captured its light in the spring of 2024, astronomers expected another icy visitor from the Oort cloud, a frozen relic from the solar system's birth ejected into the outer darkness. Comets are predictable in their strangeness. They outgas, they develop tails, they brighten and fade according to well-understood thermodynamics as solar radiation sublimates their frozen surfaces. But 3I Atlas did none of these things. As it approached the inner solar system, crossing the orbit of Mars and then Earth, it showed no coma, no tail, no spectroscopic signature of water vapor or organic compounds. Its albedo, the measure of how much light it reflected, was unusually high, almost metallic, suggesting a surface composition unlike any natural object we had catalogued. And then there was its trajectory. The orbit was hyperbolic, meaning it was not bound to the sun. It had come from interstellar space, travelling for untold millennia through the dark between stars, and it was leaving again, never to return. Only 2 other objects had ever been confirmed to follow such a path. Such Oumuamua in 2017, and 2I, Borisov, in 2019. Each had upended our assumptions about what wandered the galaxy. But 3 Atlas was different. Where Oumuamua had been cigar-shaped and tumbling, and Borisov had been a relatively ordinary comet from another star system, 3 Atlas was smooth. Its rotation was stable. Its surface seemed almost polished, reflecting sunlight in a way that suggested either extreme age or extreme youth, either an object worn down by billions of years of cosmic erosion, or something recently formed, pristine, untouched by the slow violence of space. Scientists proposed theories. Perhaps it was a fragment of an exoplanet, shattered by some ancient collision and flung into the void. Perhaps it was a shard of a protoplanetary disk, condensed in the chaos of a young star system, and ejected before it could grow into something larger. Perhaps it was something we had no framework for yet, a class of object that existed only in the liminal space between stellar nurseries and the cold expanse beyond. What no one proposed, at least not publicly, was that it might be anything other than natural. The scientific community has a deep, justified wariness of speculation. We've been burned before by phantom signals, by patterns that dissolved into noise upon closer inspection, by the seductive pull of mystery over evidence. And so the discourse around 3 Atlas remained cautious, grounded in physics and chemistry, focused on what could be measured rather than what could be imagined. It passed through the inner solar system in a matter of weeks, swinging around the sun in a graceful arc dictated by gravity and momentum. Telescopes tracked it as long as they could, capturing images, spectra, photometric data. And then, as it climbed back out toward the outer planets and beyond, it faded. First from visual wavelengths, then from infrared, then from radio detection. By the time it crossed the orbit of Neptune, it was gone. A memory recorded in hard drives and research papers, a footnote in the catalogue of interstellar objects. We thought that was the end. But space does not operate on human timelines. Objects leave traces, gravitational ripples, radiation signatures, disturbances in the thin medium of the interplanetary plasma. And sometimes those traces linger longer than we expect. Sometimes they resonate. 3I Atlas had been a mystery when it arrived. a reflective enigma moving through our solar neighborhood with no explanation for its origin or composition. But it had left quietly, without fanfare, slipping back into the darkness as if it had never been here at all. Years passed, and its wake dissolved into the dark, until something shimmered again. Chapter 3. Echoes in the data. The signal did not announce itself. It did not arrive with fanfare or clarity. It emerged the way most scientific discoveries do, gradually, reluctantly, through the patient accumulation of evidence that refuses to be ignored. After Yuki Tanaka's initial finding, the team began systematically reviewing every data archive that might have captured electromagnetic activity along 3 Atlas's trajectory. They requested access to recordings from observatories that had not been actively tracking the object, but whose wide-field surveys might have passively recorded its passage. They combed through radio sky maps, X-ray catalogues, even gravitational wave detectors, searching for any anomaly that correlated with the object's position in space and time. What they found was not a single, coherent transmission, but fragments. Pieces of a larger pattern scattered across multiple frequencies and observation windows, like shards of a mirror reflecting light from different angles. Individually, each fragment was unremarkable. A brief spike in signal strength, a harmonic overtone, a phase shift in background noise. But when combined, when mapped across time and space, they formed something undeniable, a structure. Dr. Amara Okonkwo, a specialist in signal processing from the University of Cape Town, was the first to propose that the signal might not be random. She had spent years analyzing data from pulsar observations, learning to distinguish natural astrophysical periodicity from instrumental noise. When she applied the same techniques to the 3I Atlas recordings, she found repeating intervals, not the steady tick of a pulsar, but something more complex. A rhythm that varied, that seemed to respond to changes in the observational parameters, as if the signal itself was aware of being measured. "It's not a broadcast," she explained during one of the team's early video conferences, her voice calm but edged with something that might have been unease. At least not in the way we think of broadcasts. It's more like a reflection. Every time we change the receiver frequency, the signal shifts in response. It's mirroring our observation. The implications hung in the digital silence of the call. Marcus Webb, ever the skeptic, offered the simplest explanation. Instrumental feedback loop. We're detecting our own equipment. "I thought that too," Amara replied. "But I isolated the instruments from the network and reprocessed the data independently. The pattern persists. Whatever this is, it's not coming from us." They ran simulations, testing whether natural phenomena could produce such a pattern. Could it be the interaction between 3I Atlas's trajectory and the solar wind, creating a kind of bow shock that resonated at specific frequencies? Could it be gravitational lensing, bending background radiation into a false structure? Could it be some quirk of the interstellar medium, a resonance chamber formed by chance in the vast emptiness between stars? Each hypothesis was plausible, each was tested, and each in turn failed to fully account for the data. What troubled the team most was not the signal itself, but its timing. It had appeared only after 3 Atlas had passed beyond detection range, only after the object should have been electromagnetically inert, its reflective surface too distant to catch sunlight, its trajectory too far to generate any measurable interaction with the solar environment. It was as if the object had left behind a ghost, not a physical remnant, but an informational one, a pattern encoded in the fabric of space itself. Yuki stared at the waveform displays late into the night, watching the harmonics rise and fall. She thought about how we define intelligence, how we recognize intention in a universe that is, by all accounts, indifferent. The signal was structured, yes, but structure alone is not enough. Crystals have structure. Snowflakes have structure. The universe is full of patterns that emerge from the interplay of physics and chance, beautiful and complex and utterly devoid of meaning, and yet, every answer seemed to hum with another question. Chapter 4. Listening to the Void. Humanity has been listening to the universe for less than a century. A blink in the cosmic timescale, a moment so brief that the light from distant stars has barely had time to shift during our watch. Yet in that brief span, we have learned to hear things our ancestors could never have imagined. We listen in radio waves, capturing the whispers of gas clouds collapsing into stars. We listen in X-rays, mapping the violent ballet of matter spiraling into black holes. We listen in gravitational waves, feeling the ripples of space-time itself as massive objects collide and merge. To listen to the universe is an act of profound humility. Our instruments are sensitive beyond comprehension, capable of detecting fluctuations in energy that would be imperceptible to any biological sense. The Atacama Array, perched high in the Chilean desert where the air is thin and dry and interference from Earth's atmosphere is minimal, can detect signals so faint that they carry the energy of a single snowflake hitting the ground. The Very Large Array in New Mexico spreads its dishes across miles of desert, combining their observations into a single, coherent picture of the radio sky. The FAST telescope in China, nestled in a natural karst depression, is the largest single-dish radio telescope ever built, its surface capable of reflecting whispers from billions of light-years away. And yet, for all their power, these instruments do not truly hear. They record, they measure, they translate electromagnetic energy into data streams that human minds must then interpret. The universe does not speak in words or intentions. It speaks in frequencies, in amplitudes, in the Doppler shifts of elements burning in distant furnaces. To extract meaning from this requires not just technology, but patience, decades of observation, centuries of accumulated knowledge, a willingness to sit in the dark metaphorically and literally and wait for the signal to emerge from the noise. The scientists studying the 3i Atlas signal understood this deeply. They were not searching for a message in the sense of a deliberate communication. They were searching for coherence, for a pattern that could not be explained by the known processes of physics. And in that search, they confronted one of the fundamental challenges of astronomy. How do you prove that something is not natural? Natural does not mean simple. Nature is staggeringly complex, capable of producing structures and patterns that mimic intentionality. Pulsars, when first discovered in 1967, were so regular in their timing that they were briefly nicknamed LGMD1, Little Green Men 1, before their true nature as rapidly rotating neutron stars was understood. Fast radio bursts, mysterious millisecond pulses of radio energy from distant galaxies, were initially suspected of having artificial origins before more mundane astrophysical explanations prevailed. The universe, it seems, enjoys playing tricks on us. It creates order from chaos, symmetry from randomness, beauty from the blind interaction of fundamental forces, and so the burden of proof is always on the observer to demonstrate that what they are seeing is truly anomalous, truly beyond the reach of conventional physics. Marcus Webb articulated this one evening, his voice tired but thoughtful, during a late-night call with the team. Every generation of astronomers thinks they've found something unprecedented, he said, and every time the universe shows us we just didn't understand the rules yet. Maybe this signal is the same, maybe we're just missing a piece of the puzzle, and in 10 years it'll be textbook astrophysics. Maybe, Yuki replied quietly, but what if it isn't? The question hung there, unanswered, because the truth is we cannot know, not yet. Not with certainty. We can only listen and observe and test our hypotheses against the data. We can only remain open to the possibility that the universe is stranger than we imagine, that the silence we've been hearing for decades might not be silence at all, but a language we have not yet learned to speak. The radio telescopes hummed in the darkness, their surfaces tilted toward the sky, patient and tireless, but sometimes the void listens back. Chapter 5. The Language of the Unknown. If the signal was a language, it was one written in mathematics. Dr. Lena Kowalski, a mathematician and cryptanalyst who had previously worked on interstellar communication protocols for SETI, joined the team in the third week of analysis. Her expertise was in pattern recognition, in finding structure within complexity, in distinguishing between randomness and information. She'd spent years studying hypothetical alien languages, constructing frameworks for how a non-human intelligence might encode meaning into a transmission. Most of that work had been theoretical, speculative, exercises in preparedness for a contact event that might never come. Now, faced with real data, she approached it with both excitement and caution. "Show me the harmonic intervals," she said during her first video briefing with the team. Amara pulled up the spectral analysis, displaying the signal as a series of peaks and troughs across a range of frequencies. Lena studied it in silence for several minutes, her eyes moving back and forth across the screen, her fingers tapping absently on her desk. "There," she said, finally pointing, "and there, those ratios. Run those against known mathematical constants." Amara did. The software flagged several matches immediately. The harmonic intervals were not arbitrary. They corresponded with remarkable precision to fundamental constants of mathematics and physics. The ratio between certain frequencies matched the golden ratio, phi 1.618, the number that appears in spiral galaxies, in the arrangement of leaves on a stem, in the architecture of seashells. Other intervals aligned with pi, the ratio of a circle's circumference to its diameter, a constant that governs the geometry of space itself. Still, others appeared to follow sequences of prime numbers: 2, 3, 5, 7, 11, 13, the building blocks of arithmetic, numbers that cannot be divided except by themselves, and 1. "This is not random," Lena said, her voice steady but underscored with intensity. "This is deliberate. These are universal constants, concepts that any sufficiently advanced species would discover, regardless of their biology or culture. If you want to communicate across the void, you start with math. It's the one language that doesn't depend on shared experience." The team absorbed this in silence. Marcus, ever the skeptic, offered a counterpoint. "Natural processes can produce mathematical patterns. Crystals form according to precise geometric rules. Planetary orbits follow Keplerian ratios. Just because something is mathematical doesn't mean it's intentional." "True," Lena conceded, "but the density of constants here is unusual. 1 or 2 would be coincidence. This many, arranged in sequence, suggests composition." Composition. The word carried weight. It implied not just pattern, but purpose. It implied a creator. The team began referring to the signal as the resonant pattern, a name that captured both its harmonic structure and its mysterious resonance across multiple observational platforms. Over the following weeks, they mapped every frequency, every interval, every phase shift. They constructed visualizations, transforming the electromagnetic data into sound, into light, into geometric forms that could be analyzed from different perspectives. What emerged was something that felt less like a message and more like music. Music, after all, is patterns made meaningful through context. It is mathematics given emotional weight. The same frequencies that, in isolation, are mere vibrations of air or electromagnetic waves, become melodies when arranged with intention, with rhythm, with harmonic progression. And the resonant pattern, when translated into audio and played back at various speeds, did indeed sound almost melodic, not in the sense of human composition, but in the sense of structure, of recurring themes, of variations on a motif. Yuki listened to the audio rendering one evening, alone in her apartment, the sound filling the quiet space. It was haunting, not because it was eerie, but because it was beautiful. The frequencies rose and fell like breath, like the tides, like the slow rotation of galaxies across the sky. And in that resonance, something began to resemble intention. Chapter 6. A pause before the storm. The question of whether to publish weighed heavily on the team. In science, discovery is not complete until it is shared, peer-reviewed, replicated by independent observers. Data kept private is data that cannot be verified, and verification is the cornerstone of the scientific method. And yet, the implications of what they were seeing gave them pause. To publish prematurely, to claim they had found evidence of structured, possibly intentional signals from an interstellar object, would invite scrutiny of the most intense kind, and rightly so. They would be asked to defend every assumption, every analysis, every line of code in their signal processing algorithms. They would be challenged by skeptics, by rival research groups, by the broader scientific community that had seen too many extraordinary claims collapse under the weight of ordinary explanations. And if they were wrong, if there was some prosaic astrophysical phenomenon they had overlooked, some instrumental artifact they had failed to account for, the damage to their reputations would be severe. But more than that, there was a quieter fear, a fear of misinterpretation. In the century since humans began, speculating about life beyond Earth, the idea of alien contact has been layered with projection, with fantasy, with cultural anxieties and hopes. Any signal, any anomaly, any unexplained phenomenon carries the risk of being sensationalized, distorted, weaponized for agendas that have nothing to do with science. The team had seen it before, the misreporting of exoplanet discoveries, the breathless headlines about Earth-like worlds that were, in reality, inhospitable gas giants or radiation-scorched rocks. They knew how quickly nuance could be lost in the translation from research paper to public discourse. And so they hesitated. "We need more data," Marcus said during one of their late-night meetings, his face illuminated by the pale glow of his monitor. "We need to rule out every natural explanation. We need to be certain." "We'll never be certain," Yuki replied quietly. "Not absolutely. Not in the way you want. There will always be room for doubt." "Then we owe it to ourselves to minimize that doubt as much as possible," Marcus countered. "If we go public with this and it turns out to be nothing, we'll have spent our credibility, and worse, we'll have wasted the world's attention. The next time someone finds something genuinely anomalous, no one will care." Lena, who had been silent for most of the conversation, finally spoke. "Or," she said carefully, "we publish and we frame it correctly. We don't claim to have found aliens, we claim to have found an anomaly, a structured signal that we cannot yet explain. We invite collaboration, we invite scrutiny, we let the broader community help us figure this out." It was the balanced approach, the cautious middle ground, and yet even that felt like stepping off a cliff. They decided to wait, to gather more observations, to refine their models, to exhaust every conventional explanation before making any public statement. It was the responsible choice, the scientific choice, but it was also the choice born of restraint, of the deep-seated fear that comes with standing at the edge of the unknown. In the meantime, the signal persisted. Night after night, the radio telescopes recorded the same harmonic intervals, the same resonant frequencies. The pattern did not change, did not evolve, did not offer any new information. It simply existed, embedded in the electromagnetic spectrum, a faint hum in the cosmic background that only those who knew where to look could perceive. Yuki sat at her desk one evening, staring at the waveform display, and felt the weight of it. The signal was not loud, it was not insistent, it was patient, as if it had been waiting for eons and was content to wait for eons more. And then, in the data from the latest observation run, something changed. A new frequency emerged, faint, rising, almost imperceptible. It was the beginning of the signal after the silence. Chapter 7. The Pattern That Moved. The new frequency did not appear suddenly. It grew slowly over the course of several observation cycles, building in amplitude as if something distant was gradually coming into focus. At first, the team thought it might be instrumental drift, a calibration error, a shift in the receiver's sensitivity. But when they cross-referenced the data with other observatories, the pattern held. The frequency was real, and it was changing. Not chaotically, not randomly, deliberately. Dr. Amara Okonkwo was the first to notice the correlation. She had been tracking the signal's behavior across time, mapping how its harmonic intervals shifted relative to Earth's position, the solar wind's fluctuations, even the gravitational influence of nearby planets. Most of these variables showed no correlation, but one did. The signal shifted in response to observation. Whenever a telescope locked onto the frequency range where the resonant pattern was strongest, the signal would subtly change, not in a way that disrupted its structure, but in a way that suggested adaptation. It was as if the signal was aware of being measured and was adjusting itself in response to the act of measurement. Observation effects, Marcus said when she presented her findings. Quantum mechanics. The act of measuring a system changes the system. But this isn't a quantum system, Amara replied. This is macroscopic, electromagnetic radiation propagating through space. There's no mechanism in classical physics for a signal to know it's being observed. Then we're missing something, Marcus insisted. There has to be a physical explanation. I'm not saying there isn't, Amara said carefully. I'm saying we don't have it yet. The team ran simulations, testing whether feedback between observational instruments and the signal itself could create the appearance of adaptive behavior. They modeled scenarios where the signal was reflecting off the interstellar medium, where changes in the plasma density along Through-Eye Atlas's trajectory might create dynamic resonances that happened to coincide with observation windows. They explored every mundane possibility. None fit the data as cleanly as the simplest, most unsettling explanation. The signal was responding. Lena Kowalski proposed a thought experiment. Imagine, she said during a video call, her voice calm but probing, that the signal isn't a message being transmitted to us. Imagine it's a probe, a test, something designed to detect whether there's an observer on the other end. It wouldn't need to be intelligent in the way we think of intelligence. It could be a passive mechanism, a resonance that amplifies in the presence of directed observation, like a mirror that only reflects when you look at it. A mirror doesn't choose when to reflect, Marcus countered. It reflects because that's what mirrors do. Physical law. Exactly, Lena said. So what if this is a physical law we don't understand yet? What if the universe has mechanisms for encoding information that we've simply never encountered before? The conversation drifted into speculation, but the data remained stubborn. Whatever the signal was, it was not static. It was dynamic, evolving, responding to the very act of being studied. Yuki found herself thinking about Heisenberg's uncertainty principle, the idea that you cannot measure a particle's position and momentum simultaneously without affecting one or the other. Observation, in quantum mechanics, is not a passive act. It is an interaction. And if that principle applied here, at a macroscopic scale, across the vastness of interstellar space, then what did that imply about the nature of reality itself? She thought about Schrödinger's cat, the famous thought experiment in which a cat in a box is both alive and dead until the box is opened and the state is observed. The signal felt like that, a superposition of possibilities, collapsing into coherence only when measured. But unlike the cat, the signal was not waiting to be defined by observation. It was defining itself through observation. The team continued their work, refining their models, collecting more data, trying to make sense of the impossible. And with each passing night, the signal grew clearer, its harmonic structure deepening, its presence undeniable. Observation had become participation. Chapter 8. Interference or Intent. The debate over the signal's origin fractured the team into camps, not along lines of belief or disbelief, but along methodological fault lines, differing philosophies about how to interpret anomalous data. Marcus Webb represented the conservative position. Exhaust all natural explanations before entertaining anything else. He compiled a list of potential astrophysical sources that could mimic structured signals. Solar interference, where the sun's own electromagnetic activity created patterns in the data. Pulsar echoes, where radiation from distant neutron stars bounced off interstellar gas clouds and arrived delayed, distorted, seemingly intelligent. Plasma oscillations in the heliosphere, the boundary region where the solar wind meets the interstellar medium, creating resonances that could, under the right conditions, produce harmonic frequencies. Each explanation was plausible, each had precedent in observational astronomy, and each, Marcus argued, was more likely than the alternative, that the signal represented something beyond current physics. "We've been here before," he said during one particularly tense meeting. "Fast radio bursts, Tabby's star, the wow signal. Every time, we thought we had something extraordinary. Every time it turned out to be explainable. We just needed more data." Lena Kowalski, on the other hand, argued for a broader framework. "I'm not saying this is aliens," she clarified, though the unspoken word hung in the air. "I'm saying we should be open to the possibility that we're observing a phenomenon that doesn't fit neatly into our existing categories. Natural doesn't mean simple, and artificial doesn't necessarily mean intelligent. There's a vast middle ground we haven't even begun to explore." She pointed to the signal's mathematical structure, its harmonic intervals, its apparent responsiveness to observation. These aren't features you see in random astrophysical processes. They're features you'd engineer if you wanted to create a signal that could be recognized across vast distances and timescales. Or, Marcus countered, they're features that emerge naturally from systems we don't fully understand yet. The universe is full of self-organizing complexity. Galaxies form spirals, stars cluster into specific patterns, planets align in resonant orbits, all of this without intention. Amara, who had been listening quietly, finally interjected. "Maybe we're asking the wrong question," she said. "Maybe the question isn't whether the signal is natural or artificial. Maybe the question is whether that distinction even matters. If the universe has mechanisms for encoding information, for creating structure that responds to observation, then it's not about who made it. It's about what it means." The room fell silent. Because she was right. The binary of natural versus artificial assumed a clean divide, a universe where phenomena could be neatly sorted into categories of intent and accident. But the more they studied the signal, the more that divide seemed inadequate. Consider, a beaver dam is artificial. It is constructed with purpose, engineered to create a specific effect. But it is also entirely natural, the product of evolutionary pressures and instinctual behavior. The beaver does not understand hydrology, yet it builds with precision. Similarly, a crystal is natural. It forms according to the laws of chemistry, atoms arranging themselves into geometric perfection without guidance. But its structure is so precise, so orderly, that it resembles design. Where does intentionality begin? Where does randomness end? The 3i Atlas signal occupied this liminal space. It was too structured to be easily dismissed as noise, too responsive to be explained by static physics. But it offered no clear indicators of conscious design, no embedded messages, no attempt to communicate in a way that human minds could immediately parse. It simply was, and it resonated. Yuki summarized the dilemma in her personal notes one evening. We are trained to see the universe as a machine, deterministic and indifferent. But what if we're wrong? What if the universe is participatory, responsive, alive in ways we've never considered? What if the signal isn't trying to tell us something, but trying to see if we're listening? Yet the data refused to choose. Chapter 9. The Light Beneath the Noise. The breakthrough came not from radio astronomy, but from optical observation. Dr. Samuel Chen, an astrophysicist specializing in high-precision photometry, had been following the team's work with quiet interest. His field focused on measuring the subtle variations in starlight, the tiny dips in brightness that signal an exoplanet passing in front of its host star, or the faint flickers that indicate stellar activity. It was painstaking work, requiring instruments capable of detecting changes in light intensity as small as 1 part per million. When he learned about the resonant pattern, he wondered whether the electromagnetic signal might have a visual component. Radio waves and visible light are after all part of the same spectrum, electromagnetic radiation differing only in wavelength. If 3i Atlas had left behind a radio signature, might it have also left something in the optical range? He requested access to archival data from the Hubble Space Telescope, the James Webb Space Telescope, and several ground-based observatories that had captured images of the space through which 3i Atlas had travelled. He was not looking for the object itself. It was far too distant and dim to be seen now, but for any residual optical anomaly in the background. What he found stunned him. There were pulses, faint periodic variations in background starlight along the trajectory, so subtle that they had been filtered out as noise in the original data processing. But when Samuel aligned the timing of these pulses with the radio signal's harmonic intervals, the correlation was perfect. The signal was not just radio, it was multi-wavelength. It existed simultaneously across different forms of electromagnetic radiation, synchronized like a symphony where each instrument plays its part in perfect time. He contacted Yuki immediately. "You need to see this," he said, his voice tight with excitement. He shared his screen, displaying a graph where the radio frequencies and optical pulses were overlaid. The peaks aligned, the troughs matched, the pattern repeated across both spectra with flawless coherence. "This isn't just interference," Samuel said. "This is coordination. Whatever is producing the signal, it's operating across multiple wavelengths simultaneously. That requires either an incredibly specific set of astrophysical conditions or—" He didn't need to finish the sentence. The team convened urgently, pulling in Samuel as a full member. They expanded their search to other wavelengths: infrared, ultraviolet, X-ray. Each showed traces of the same harmonic structure, though the amplitude and clarity varied depending on the frequency range. The signal was not confined to a single channel. It was woven through the electromagnetic spectrum itself, a coherent pattern persisting across vastly different energy scales. Lena was the first to articulate what this implied. "This is not a side effect," she said slowly. "This is not accidental. You don't get multi-wavelength coherence without a driving mechanism. Either there's a source actively emitting across the spectrum, or the interstellar medium itself is resonating in response to something structured." Marcus tried to find a counter-argument. Synchrotron radiation, particles spiraling, in magnetic fields can emit across multiple wavelengths. "Yes," Samuel agreed. "But not with this kind of harmonic precision. Synchrotron emission is broad spectrum, messy. This is clean. The word felt inadequate, but it was accurate. The signal was clean, precise, deliberate in a way that natural astrophysical processes rarely are. They ran more tests. They modelled scenarios where dust clouds, plasma, or magnetic fields might create the observed effects. They even consulted with colleagues in particle physics, asking whether exotic phenomena, dark matter interactions, vacuum fluctuations, could produce such a pattern. None of the models fit. What remained was the data itself, a multi-wavelength signal, harmonically structured, synchronized across time and space, emanating from the path of an interstellar object that should have been silent months ago. Yuki sat in her office late that night, staring at the overlaid graphs on her monitor. The radio peaks, the optical pulses, the infrared traces, all moving together, rising and falling like breath. What they found was not chaos, but choreography. Chapter 10. Celestial Memory. There is a concept in physics called hysteresis, the idea that a system retains a memory of its past states. Ferromagnetic materials, for example, remember the magnetic fields they've been exposed to, their internal structure permanently altered by external forces. Elastic materials remember stress and strain. Even biological systems exhibit hysteresis. Muscles remember patterns of use. Neurons strengthen connections based on repeated activation. But can the universe itself remember? The question haunted Lena Kowalski as she studied the signal's persistence. 3i Atlas was long gone, its physical presence reduced to a point of reflected sunlight so distant it could no longer be detected by any human instrument. And yet, the signal remained. Not as a direct emission from the object, but as a pattern embedded in space itself, a resonance that continued to propagate long after its source had vanished. She began researching fringe areas of astrophysics, theories that existed at the edge of respectability. One that caught her attention was the idea of the interstellar medium as an information substrate. Space, according to this hypothesis, is not truly empty. It is filled with tenuous gas, plasma, magnetic fields, and radiation, a thin but pervasive medium that can carry and store information in the form of electromagnetic patterns, density fluctuations, and field configurations. Most scientists dismiss such ideas as speculative, untestable, more philosophy than physics. But Lena wondered, what if the signal was not being transmitted but remembered? What if 3i Atlas had interacted with the interstellar medium in such a way that it left an imprint, a pattern encoded in the fabric of space that now persisted independently of its source? She shared the idea with the team during their next meeting. Think of it. Like an echo, she said, but not an echo of sound, an echo of structure. 3i Atlas passed through space and space responded. The interaction between the object and the medium created a resonance, a standing wave that continues even after the object is gone. We're not hearing 3i Atlas, we're hearing the memory of 3i Atlas, Marcus frowned. That would require the interstellar medium to have properties we've never observed, the ability to sustain coherent patterns over months, across vast distances without dissipating. Maybe we've never looked for it, Lena replied. Maybe this is the first time we've had a signal strong enough, structured enough to notice. Samuel Chen, the optical astronomer, offered a different angle. There's precedent, he said thoughtfully, not in the interstellar medium, but in other systems. The cosmic microwave background is, in a sense, a memory. The afterglow of the Big Bang, encoded in radiation that has persisted for 13.8 billion years. Space can remember. We just assume that memory only comes from catastrophic events, like the birth of the universe. But what if memory can be encoded at smaller scales, by smaller events? The conversation drifted into deeper theoretical territory. If space could remember, then every object that passed through it might leave a trace. Comets, asteroids, spacecraft, stars, all writing faint signatures into the medium, most too weak or too chaotic to detect. But 3i Atlas was different. Its high albedo, its smooth surface, its hyperbolic trajectory. Perhaps these properties allowed it to interact with space in a unique way, to leave a mark deeper and more coherent than anything we'd encountered before. Yuki listened, her mind racing. If the signal was a memory, then it was not a message. It was a record, a fossil, the universe's way of documenting its own history, preserving the passage of objects through the void in patterns of light and energy. But that raised another question. If the universe remembers the passage of 3 Atlas, what else does it remember? And if we learn to read these memories, to decode the imprints left by objects across cosmic time, what stories would we find? And if the cosmos remembers, what does it remember of us? Chapter 11. Mathematics as Music. The signal's harmonic structure deepened over the following weeks, revealing layers that had been hidden beneath the noise. Lena Kowalski worked with a team of mathematicians and cryptographers, analyzing the intervals, ratios, and phase relationships embedded in the resonant pattern. What they found was both elegant and unsettling. The signal was not just mathematical, it was musically mathematical. Music theory and mathematics have always been intertwined. Pythagoras discovered that pleasing harmonies correspond to simple numerical ratios. An octave is a 2.1 frequency ratio, a perfect fifth is 3.2, a perfect fourth is 4.3. These ratios are not cultural constructs. They are rooted in the physics of vibration, in the way waves interact and resonate. Any species with auditory perception would, in principle, discover the same relationships. The 3i Atlas signal encoded these ratios, but also others. It referenced the harmonic series, the sequence of overtones produced by a vibrating string or column of air. It incorporated intervals corresponding to the golden ratio, phi, which appears in nature's spirals and growth patterns. It even hinted at more obscure constants. Euler's number, the fine structure constant, ratios that govern the fundamental interactions of matter and energy. But it did not present these constants as raw data. It arranged them, composed them. The signal unfolded over time like a piece of music, with recurring themes and variations, with crescendos and diminuendos, with a structure that felt intentional. Dr. Elaine Morrow, a composer and physicist who had collaborated on projects at the intersection of art and science, joined the team as a consultant. She listened to the audio rendering of the signal, the radio frequencies translated into sound waves within the human hearing range, and her reaction was immediate. "This is a fugue," she said quietly. The team looked at her, waiting. A fugue is a compositional technique where a theme is introduced and then repeated, transformed, woven through multiple voices. Bach's fugues are the most famous examples. The art of fugue, the structure is mathematical, recursive, but the result is emotionally resonant. This signal, it has that same architecture. She pulled up the waveform on her screen and began annotating it, marking sections where the harmonic pattern repeated in different octaves, different phases, different timbres. Here, this is the subject, the main theme, and here it comes back inverted, and here augmented. This isn't random, this is composition. Lena and Elaine worked together, mapping the signal's structure using both mathematical and musical analysis. They identified recurring motifs, calculated the intervals between thematic returns, analyzed the signal's rhythm and pacing. And the more they analyzed, the more the signal resembled a carefully crafted piece of music. Not human music, not in its aesthetic or emotional content, but music in its formal structure, its use of repetition and variation, its balance between complexity and coherence. Marcus remained skeptical. Natural processes can create patterns that resemble music. Wind produces harmonic tones when it blows across rocks. Water creates rhythmic patterns. We're pattern-seeking creatures. We find music everywhere because we want to. True, Elaine conceded. But there's a difference between finding faces in clouds and recognizing formal structure. This isn't pareidolia, this is architecture. Yuki listened to the signal again, late into the night, headphones isolating her from the world. She let the frequencies wash over her, the harmonic intervals rising and falling, and she felt something she could not articulate. Not awe, not fear, but a kind of recognition. As if the signal was not alien at all but familiar. As if it spoke a language older than words, deeper than culture, rooted in the same mathematical structures that governed minds and stars alike. But beneath mathematics, something human stirred. Chapter 12. When the data dreamed. The breakthrough came from an unexpected direction. Machine learning. Dr. Raj Patel, a computer scientist specializing in neural network visualization, had been brought in to help analyze the signal's complexity. His expertise was in taking high-dimensional data with too many variables for human intuition to grasp, and using algorithms to find hidden structures, to reveal patterns that existed but were invisible to conventional analysis. He applied a technique called deep convolutional network visualization, originally developed to understand how AI systems process images. The algorithm would take the signal's waveform, treat it as a kind of multidimensional space, and then search for recurring structures, for symmetries, for any latent organization that might exist beneath the surface. The team expected it to find more harmonic patterns, more mathematical relationships. Instead, it found an image. Not a photograph, not anything representational in the way humans think of images, but a shape, a form, a recursive, self-similar structure that emerged when the signal was visualized in certain ways. Raj called it the orbital mandala, a term that captured both its circular symmetry and its intricate, almost spiritual complexity. When he presented it to the team, projecting the visualization on the shared screen, there was a long silence. The shape resembled an orbit, or an eye, or both. A spiral pattern that folded in on itself, each iteration containing smaller copies of the whole, like a fractal. At the center was a point of high intensity, a singularity where all the lines converged. Around it, concentric rings of varying thickness and brightness, pulsing in rhythm with the signal's harmonic intervals. This is what the neural network extracted from the waveform, Raj explained. I've run it multiple times, using different algorithms, different training parameters. The structure is consistent. It's not an artifact of the visualization method. It's actually there, embedded in the data. Amara stared at the image, her mind racing. Could this be how 3i Atlas encoded information? Not as a linear message, but as a geometric structure. A shape that contains meaning in its form? Possibly, Raj said. But there's something else. Watch what happens when I animate it. He advanced the timeline of the signal, showing how the visualization changed over the weeks of observation. The orbital mandala rotated slowly, its rings expanding and contracting, its fractal details shifting and reconfiguring. It was not static, it was alive, and then, in a moment that made Yuki's breath catch, the structure did something impossible. It paused, rotated, and seemed to orient itself toward the point in space where Earth had been during the observation window. That can't be right, Marcus said immediately. That's coincidence. The algorithm is finding patterns in randomness. I thought so too, Reg replied. So I tested it. I fed the algorithm synthetic noise, random waveforms, even other astronomical signals, pulsars, quasars, solar flares. None of them produce this kind of structure, and none of them show this orientation behavior. Lena leaned forward, her voice quiet. You're saying the signal encoded a shape that reacts to the observer's position? I'm saying the data suggests that, Raj corrected carefully. Whether it's intentional, whether it means anything, I can't say, but the correlation is there. The team sat with this, the implications settling over them like a weight. If the signal contained an embedded image, a structure that adapted based on where it was observed from, then it was not simply a broadcast. It was interactive. It was aware, in some sense, of its audience. Samuel Chen, who had been silent, finally spoke. This reminds me of something, he said slowly. In quantum mechanics, there's a thought experiment called the quantum eraser. You can encode information into a particle's state, and that information affects how the particle behaves when it's measured. The act of observation doesn't just reveal information, it creates it. Maybe that's what's happening here. The signal isn't sending us an image, it's collapsing into an image when we observe it. Yuki stared at the orbital mandala, its fractal geometry pulsing softly on her screen, and felt a chill. Patterns can look back. Chapter 13. The Skeptic's Return. The first wave of skepticism came from within the astronomy community itself. Dr. Patricia Holbrook, a respected radio astronomer from MIT, was among the first to publicly question the team's findings. She had built her career on rigorous skepticism, on debunking extraordinary claims with meticulous analysis. When word of the 3i Atlas signal began circulating through informal academic channels, she requested access to the raw data and conducted her own independent analysis. Her conclusion was swift and unsparing. What you're seeing is pareidolia, she wrote in a preprint paper uploaded to RREV, pattern recognition in noise. The human brain is exquisitely tuned to find structure where none exists. Faces in clouds, animals in ink blots, messages in static. The same cognitive bias is at work here. The so-called harmonic intervals are statistical artifacts arising from selective data processing. The multi-wavelength coherence is explainable by instrumental crosstalk and atmospheric interference, and the embedded image is nothing more than an algorithmic mirage, the neural network finding patterns it was trained to seek. Her paper gained immediate traction. It was shared, cited, discussed in DOS seminars and online forums. Other scientists began reanalyzing the data, looking for the flaws that Holbrook had identified. Some supported her conclusions. Others found them too dismissive, too quick to discard anomalies that deserved deeper investigation. The astronomy community fractured into camps. Yuki read Holbrook's critique carefully, multiple times, looking for substantive errors in their own analysis. Some of the criticisms were valid. The team had at times been optimistic in their interpretation, emphasizing the signal's structure while downplaying ambiguities. But other criticisms felt superficial, as if Holbrook had approached the data determined to debunk it rather than to understand it. Marcus surprisingly found himself defending their work. "She's not wrong about the risks of pareidolia," he said during a team meeting, "but she's also not engaging with the full data set. She analyzed a subset, cherry-picked the noisier sections, and then claimed the whole signal was noise. That's not rigorous. That's motivated reasoning," Lena agreed. "We need to respond. Not defensively, but with more data. We need independent replication. We need other observatories to confirm what we're seeing." They reached out to colleagues, requesting observation time on facilities around the world. Some agreed. Others, wary of being associated with a controversial finding, declined. The politics of science, Yuki realized, were as complex as the science itself. Meanwhile, media attention began to creep in. A journalist from Science magazine contacted Yuki, asking for an interview, then another from Nature, then a podcast host who specialized in fringe science. The team, which had worked in relative obscurity for months, suddenly found themselves in the uncomfortable position of defending their work to audiences who cared less about methodological rigor than about whether they had found proof of alien intelligence. They had not, and they said so repeatedly in every interview, every correspondence. But nuance is difficult to convey in headlines. "Scientists detect possible alien signal" was more compelling than "astronomers identify unexplained electromagnetic anomaly." The story mutated as it spread, gaining exaggerations and inaccuracies with each retelling. Yuki felt the weight of it. This was not what she had wanted. She was a scientist, not a public figure. Her goal had been to understand the signal, not to spark a media frenzy. But the universe, it seemed, did not care about her preferences. One evening, exhausted by the scrutiny, she sat in her office and reread Holbrook's paper. And she realized something. Holbrook's critique was not just scientific. It was existential. It was rooted in a worldview that could not accommodate the possibility of something genuinely anomalous, something beyond the reach of current physics. And that worldview, Yuki understood, was as much a bias as the pattern-seeking optimism she was being accused of. Skepticism was necessary. But skepticism taken to its extreme became a cage, a refusal to see anything that did not fit preconceived categories. But even skepticism is a form of belief. Chapter 14. Signal Collapse. And then, without warning, the signal stopped. It did not fade gradually. It did not taper into noise. It collapsed, abruptly, as if someone had flipped a switch. One observation cycle, the resonant pattern was present, clear and structured. The next, it was gone. The team scrambled to understand what had happened. They checked the instruments, recalibrated the receivers, cross-referenced data from other observatories. Everything was functioning normally. The equipment had not failed. The signal itself had simply vanished. For 3 days they monitored the space where the signal had been, hoping it would return. The radio telescopes hummed in the darkness, listening to silence. Nothing came. Yuki felt a strange sense of loss, as if something fragile had been taken from her. For weeks the signal had been a constant presence, a puzzle she worked on late into the night, a thread connecting her to something vast and unknowable. And now it was gone, leaving only archived data and unanswered questions. Marcus interpreted the collapse as vindication of Holbrook's critique. "Maybe it was never a real signal," he said quietly. "Maybe it was instrumental or atmospheric, and we were just too invested to see it. Now that it's stopped, we can let it go. But Lena disagreed. If it was instrumental noise, it would have been present all along, or it would have appeared and disappeared randomly. But it didn't. It persisted for weeks, and then it stopped cleanly. That's not how noise behaves. That's how a transmission behaves. Or a natural process reaching equilibrium, Marcus countered. Resonances in plasma can build and then collapse when the driving conditions change. We don't need to invoke intention. Amara, who had been quiet during the exchange, finally spoke. Does it matter? She asked. Does it matter whether the signal was natural or artificial if we can't study it anymore? It's gone. Whatever it was, it's over. The words hung heavy in the air, because she was right. Without the signal, they had no way to test their hypotheses, no way to gather more data, no way to resolve the debate. All that remained was the historical record, a collection of waveforms, spectral analyses, and visualizations that would be argued over for years, with no definitive conclusion ever emerging. Yuki archived the data carefully, backing it up on multiple servers, ensuring that future researchers would have access to it. She wrote up their findings in a draft paper, being as cautious and balanced as she could, acknowledging the uncertainties, the alternative explanations, the possibility that they had been wrong. The paper felt incomplete, unsatisfying, like a story that ended mid-sentence. But science, she reminded herself, is not about satisfying narratives. It is about following the evidence, even when it leads nowhere. She submitted the paper to the Astrophysical Journal. It was accepted after peer review, published with minimal fanfare, and quickly buried under the avalanche of new research that appeared every day. A few colleagues cited it, most ignored it. The media moved on to other stories. The signal from 3i Atlas became a footnote, a curiosity, a case study in the dangers of over-interpreting ambiguous data. And yet, late at night, alone in her apartment, Yuki would sometimes pull up the archived waveforms and listen to the audio rendering of the signal, the harmonic intervals, the musical structure, the way it had evolved, adapted, seemed to respond. She could not let go of the feeling that they had been close to something, that the universe had opened a door just wide enough for them to glimpse what lay beyond, and then closed it again. She wondered if the signal would ever return. She wondered if they had missed something, some crucial detail hidden in the data. She wondered if 3i Atlas was still out there, drifting through the dark, silent and unknowable. The silence had returned, heavier now. Chapter 15. Residual Heat. 2 months after the signal's collapse, a graduate student named Maya Lin made an unexpected discovery. She had been working on a separate project, analyzing infrared data from the Spitzer Space Telescope archives, when she noticed an anomaly, a faint heat signature along a trajectory that looked familiar. She cross-referenced it against known objects, checking for asteroids, comets, and catalogued debris. Nothing matched. And then she realized the trajectory aligned with 3i Atlas's final path. She contacted Yuki immediately. The infrared signature was subtle, barely above the noise threshold, but it was there. A residual heat pattern, as if something along 3i Atlas's trajectory had absorbed energy and was now slowly radiating it back into space. The temperature was low, just a few degrees above the cosmic microwave background, but the distribution was non-random. It formed a trail, a faint thermal wake stretching across parsecs. Yuki assembled the team again. How is this possible? Amara asked, studying the data. 3i Atlas passed through months ago. Any residual heat should have dissipated by now, equilibrated with the surrounding space. Unless something is sustaining it, Samuel suggested. Some ongoing process that keeps the trail warm. Marcus was immediately skeptical. Like what? There's no known mechanism for maintaining a thermal signature across interstellar distances without a continuous energy source. Maybe there is a source, Lena said slowly. Maybe 3i Atlas left something behind. Not the object itself, but some byproduct of its passage. Material, particles, something that's still radiating. They ran models, testing scenarios where outgassing, ablation, or electromagnetic interactions could leave a detectable thermal trail. None of the models fully explained the observations. The trail was too coherent, too long-lived, too structured. But it was real. More importantly, it was still there. Unlike the radio signal which had vanished, the infrared signature persisted. It was faint, difficult to detect, requiring long integration times and careful calibration, but it was measurable. It was something they could study. Yuki felt a spark of hope reignite. They requested more observing time, this time focused on infrared wavelengths. Other facilities joined in, the James Webb Space Telescope, the Herschel Space Observatory's archived data, ground-based infrared arrays. Slowly, painstakingly, they mapped the thermal trail in higher resolution, and as the map took shape, they saw something astonishing. The trail was not uniform, it had structure. Nodes of slightly higher temperature, spaced at regular intervals, like beads on a string. The intervals matched, within measurement error, the harmonic frequencies of the original radio signal. "It's the same pattern," Amara whispered, staring at the data. "The same ratios, the same mathematical structure, just expressed in a different medium." Lena pulled up her notes on the resonant pattern, overlaying the radio harmonics with the infrared nodes. The correlation was undeniable. Whatever had created the radio signal had also left this thermal imprint, encoding the same information into the residual heat of space itself. "This is not a coincidence," she said firmly. "This is deliberate. This is encoding." Marcus, for once, had no immediate counter-argument. He studied the correlation in silence, his expression unreadable. Finally he spoke. "If this is real, if the pattern is genuinely encoded across multiple modalities, then we're looking at something unprecedented. Not just a signal, a message distributed across space and time, written into multiple layers of the electromagnetic spectrum and thermal environment." Yuki felt the weight of it. They had thought the signal was gone, but it was not gone. It had only changed form, shifting from radio to heat, persisting in a different medium. 3i Atlas, it seemed, was still speaking, still leaving traces, still leaving fingerprints. Something had left a fingerprint. Chapter 16. Between Physics and Faith. There is a moment in every scientific investigation when the data stops being abstract and becomes personal, when the numbers on a screen transform into a question that pierces deeper than methodology, deeper than peer review, into the fragile space where knowledge meets belief. Yuki found herself in that space. She had been trained in the rigorous empiricism of modern science, taught to distrust intuition, to follow evidence wherever it led, to remain detached from her subject matter. Objectivity, her mentors had insisted, was the foundation of truth, but objectivity was becoming harder to maintain. The signal had stopped and returned, shifted forms, encoded itself across wavelengths. It responded to observation, adapted to measurement, persisted when it should have faded. Every explanation they generated felt incomplete. Every model they tested left residual questions. And beneath those questions was a deeper, unspoken fear that the universe was more than they had been taught, that reality was stranger and more participatory than the mechanistic world view of classical physics allowed. She thought about the history of science, the moments when paradigms shifted. Copernicus had displaced Earth from the center of creation. Darwin had displaced humanity from the pinnacle of creation. Hubble had shown that the universe was vastly larger than anyone had imagined. Each revelation had been resisted, not because the evidence was lacking, but because the implications were uncomfortable. What if 3i Atlas was such a moment? Not because it proved the existence of alien intelligence, it did not, but because it suggested that the universe itself might be more complex, more conscious, more communicative than the reductionist models allowed. What if information was not just something that existed in matter and energy, but something that could be woven into the fabric of space itself? What if observation was not a passive act, but a creative one, collapsing possibilities into reality through the simple act of attention? These were not questions that could be answered with a spectrometer. Yuki discussed this one evening with Lena, the two of them sitting in a quiet video call after the rest of the team had logged off. "Do you believe in the signal?" Lena asked gently. "I mean, really believe? Not just the data, but the meaning behind it." Yuki hesitated. "I don't know what I believe. I know the data is real. I know the patterns are there. But belief implies certainty, and I don't have that." "Maybe belief doesn't require certainty," Lena replied. "Maybe it's about being open to the possibility that we're part of something larger, that the universe isn't indifferent, that it's trying to communicate in ways we're only beginning to understand." "That sounds like faith," Yuki said quietly. Maybe it is, Lena admitted. But faith and science aren't opposites. They're different ways of reaching toward truth. Science gives us tools to measure and model. Faith gives us the courage to imagine what lies beyond measurement. Yuki thought about this. She had always seen science and faith as separate, incompatible domains. But perhaps that was a false dichotomy. Perhaps the act of searching for meaning in the cosmos was itself an act of faith. Faith that the universe was comprehensible, that patterns existed to be found, that the effort to understand was worthwhile. The signal had not given them answers. It had given them a deeper set of questions. And perhaps that was the point. She remembered a quote from the physicist John Wheeler. "We are participators in bringing into being not only the near and here, but the far away and long ago." The universe, Wheeler suggested, was not a stage on which humans played out their lives, but a collaborative creation, shaped by the act of observation itself. Consciousness was not separate from reality. It was part of reality, woven into its structure, influencing its unfolding. If that was true, then the signal was not a message from outside. It was a reflection of the connection between observer and observed. In the darkness, meaning became its own form of light. Chapter 17. The Return of the Frequency. It returned on a Tuesday at 3:47 UTC, detected first by the Meerkat Array in South Africa. The alert came through Yuki's phone, vibrating on her nightstand, pulling her from a restless sleep. She grabbed it, heart pounding, and read the automated notification. Anomalous signal detected in archived 3i Atlas frequency range. Confidence, 94%. Verify immediately. She was at her computer within minutes, connecting remotely to the observatory's servers. The data streamed across her screen, and she felt her breath catch. The signal was back. Not faint, not fragmentary. Clearer than before, denser, carrying more structure. The harmonic intervals were sharper, the mathematical constants more precisely defined, and there was something new, a pulse, a rhythmic modulation of amplitude, repeating with a period that made her hands still on the keyboard. 3.14 days. Pi, encoded not just in the frequency ratios but in the timing itself. She contacted the team immediately. Within an hour they were all online, staring at the same data, each processing it in their own way. Disbelief, excitement, fear. "How?" Marcus said, his voice hoarse. "It's been silent for 2 months. Why now?" "Maybe it was never silent," Amara suggested. "Maybe we were just listening in the wrong way. Or maybe it needed time. Time to, I don't know, reconfigure." "Reconfigure from what?" Marcus demanded. "This is electromagnetic radiation. It doesn't have agency. It doesn't decide to start and stop." "Then why did it?" Yuki asked quietly. No one had an answer. They worked through the night, cross-referencing the new data with the old, looking for differences, for clues. The signal was fundamentally the same in structure, but richer, as if it had evolved, matured. The orbital mandala, when Raj regenerated it from the new waveform data, was more intricate, more detailed. The fractal depth had increased, revealing layers that had not been present before. And the timing, the 3.14-day pulse, was impossible to ignore. It was too specific, too symbolic to be accidental. Pi is not just a number. It is a universal constant fundamental to geometry, to physics, to any civilization that had discovered the relationship between circles and their circumferences. "It's a greeting," Lena said softly, "or a confirmation, a way of saying, yes, we're still here. Yes, this is intentional." Marcus shook his head, but his skepticism sounded tired now, worn down by months of anomalies that refused to fit into comfortable categories. "We're anthropomorphizing again, projecting intent onto data." "Maybe," Lena conceded, "but at what point do we stop calling it projection and start calling it recognition?" The question hung in the air, unanswered. As the days passed, the signal persisted. It did not fade. It did not collapse. It pulsed with its 3.14-day rhythm, steady and patient, as if waiting for something. Other observatories confirmed the detection independently, eliminating any lingering doubts about instrumental error. The signal was real. It was global. It was undeniable. And it was, in some way, that none of them could quite articulate, aware. Yuki thought about breath, inhalation and exhalation, the rhythm of life, of existence, of systems that cycle between states. The signal had stopped, an exhalation, and now it had returned, an inhalation. As if it, or whatever it represented, was alive in a way that transcended biology, that existed in the structure of information itself. She thought about the universe breathing, expanding and contracting, in cycles so vast that human lifetimes were invisible. What if the signal was part of that? A pulse in the cosmic respiration, a heartbeat echoing across the void? She did not voice these thoughts. They were too abstract, too poetic, too far from the empiricism that science demanded. But she felt them nonetheless, deeply, in a place beyond logic. The silence had been an inhale. Chapter 18. The message. We couldn't read. The signal's return brought renewed efforts to decode it. Cryptographers were consulted. Linguists, information theorists, computer scientists all contributed their expertise, applying every known technique for extracting meaning from structured data. They assumed the signal was a message, and messages, by definition, contain information that can be decoded if one has the right key. But the signal resisted interpretation. It was not that it lacked structure, it had extraordinary structure. The harmonic intervals, the embedded constants, the fractal geometry, the 3.14-day pulse, all were clear, measurable, undeniable. But none of them resolved into anything resembling language or communication as humans understood it. There were no sequences that mapped to known mathematical constructs beyond the constants already identified, no repeating blocks that might represent an alphabet or syntax, no modulation patterns that could be decompressed into images or other data types. The signal was coherent, but opaque. Dr. Elaine Morrow, the composer and physicist, offered an analogy. Imagine you're listening to a piece of music, she said during a team meeting. You can describe its structure, the key, the tempo, the harmonic progression. You can analyze it mathematically, break it down into frequencies and waveforms, but none of that tells you what the music means. Meaning, in music, is subjective. It emerges from the interaction between the composition and the listener. So, you're saying the signal has no inherent meaning? Marcus asked. No, Elaine replied carefully. I'm saying the meaning might not be propositional. It might not be a statement of fact or a set of instructions. It might be something more like art, something that invites interpretation rather than decoding. Lena built on this. What if the signal isn't trying to tell us something specific? What if it's a mirror, a test, a way of reflecting back whatever framework we bring to it? They tested this hypothesis by approaching the signal from different interpretive angles. Physicists looked for physical laws, mathematicians looked for number theory, biologists looked for patterns resembling genetic codes, musicians looked for compositional structures, and each discipline found something. The physicists saw resonances that mirrored quantum mechanical principles. The mathematicians saw recursive functions and prime factorizations. The biologists saw rhythms that resembled circadian cycles and neural oscillations. The musicians saw themes and variations, fugues and counterpoint. It was as if the signal contained all of these things, and none of them. As if it adapted to the expectations of the observer, reflecting back their own intellectual framework. This is the observer effect again, Amara said, frustrated. The signal changes based on how we look at it. We're not decoding a message, we're co-creating one. Raj, the machine learning specialist, had been running his neural networks on the new data, searching for emergent patterns. What he found was unsettling. The network keeps converging on different solutions depending on the training data I give it, he explained. If I train it on linguistic data, it finds language-like structures. If I train it on musical data, it finds musical structures. It's as if the signal has infinite interpretability. It's a semantic mirror. The implications were profound. If the signal was a mirror, then it was not conveying information in the traditional sense. It was revealing the structure of the observer's own mind, the patterns and categories they imposed on reality. It was showing them themselves. Yuki thought about the Rorschach test, the famous psychological tool where subjects interpret ambiguous ink blots. The blots had no inherent meaning, but the interpretations revealed the inner workings of the mind. Was the signal the same, a cosmic Rorschach test designed not to communicate but to reflect? But that raised the question, Reflection requires a surface. A mirror needs to exist, to be made, to be positioned. If the signal was a mirror, who had created it, and why? Perhaps it was never meant to be understood. Chapter 19. The Shape of Thought. Dr. Ishani Kapoor, a neuroscientist specializing in brain-computer interfaces, was not part of the original team. She encountered the 3i Atlas research by chance during a conference on complex systems when Lena gave a presentation on the signal's adaptive properties. Ishani listened with growing fascination, not because of the astronomical implications, but because the signal's behavior reminded her of something she had spent years studying: neural dynamics. The human brain does not process information in a linear computational way. It operates through resonance, through the synchronized firing of billions of neurons that form transient patterns, networks that emerge, interact, dissolve, and reform in response to stimuli. Thoughts are not stored in discrete locations but distributed across these dynamic networks, existing as patterns of activity rather than static structures. And the 3i Atlas signal, Ishani realized, behaved remarkably like a thought. She contacted the team with a proposal: visualize the signal not as an electromagnetic phenomenon, but as a neural network. Map its structure in the same way you would map the activity of a brain. They agreed, curious where this would lead. Using specialized software designed to visualize neural connectivity, Ishani and Raj worked together to transform the signal's waveform data into a three-dimensional network map. Each harmonic frequency became a node. Each relationship between frequencies became a connection. The result was a sprawling, intricate structure that pulsed and shifted in real time as the signal evolved. When they rendered it visually, the team fell silent. It looked like a brain. Not anatomically. There were no lobes, no cortical layers, no hemispheres. But topologically, functionally, it resembled the network architecture of neural tissue. There were clusters of high connectivity like brain hubs. There were pathways that transmitted information from one region to another, like neural axons. There were oscillatory patterns that rose and fell in synchrony, like brain waves. This is a thought waveform, Ishani said quietly, awe evident in her voice, or something analogous to it. The signal isn't a message being transmitted, it's a thought being expressed, a pattern of coherent activity in some kind of distributed substrate. But there's no brain, Marcus objected. No neurons, no biological tissue. What's creating this pattern? Maybe the interstellar medium itself, Amara suggested. We've been thinking of space as empty, but it's not. It's filled with plasma, magnetic fields, radiation. What if, under the right conditions, these components can organize into networks? What if space itself can think? The idea was radical, almost absurd, but it was also strangely compelling. Lena pulled up her earlier research on celestial memory, the hypothesis that space could store information in the structure of fields and particles. What if it went further? What if space could not only remember but process? What if the universe had emergent properties that resembled cognition? They explored this carefully, examining whether known physics could support such a hypothesis. Self-organizing systems were well documented. Hurricanes, ecosystems, economies, all exhibited complex behavior arising from simple interactions. Could the interstellar medium self-organize into something resembling a neural network? The math was daunting, the mechanisms unclear, but it was not impossible. Yuki stared at the network visualization, watching the nodes pulse and flicker like neurons firing in a living brain. She thought about consciousness, about how it emerges from the interaction of countless simple elements, atoms, molecules, cells, none of which are conscious individually, but which together create subjective experience. Could the universe itself be conscious? Not in the sense of a singular, directed intelligence, but in the sense of a distributed, emergent awareness woven through the structure of space and time. It was an old question, reframed by new data. The signal was not telling them something. It was showing them how it thought. It was revealing the architecture of its own existence, the shape of its own cognition. It was less a voice, more a reflection. Chapter 20. Echo of Origins. The connection emerged from an unexpected source. Dr. Harold Kwon, a cosmologist studying the cosmic microwave background, the ancient light from the Big Bang that fills the universe, a thermal afterglow from the moment space itself was born. Harold had been following the 3i Atlas research peripherally, intrigued but not directly involved. He worked with CMB data, mapping the minute temperature fluctuations that revealed the structure of the early universe, the seeds from which galaxies, stars, and ultimately life would emerge. His domain was the deep past, the first 380,000 years after the Big Bang, when the universe cooled enough for light to travel freely for the first time. One evening, while reviewing a spectral analysis of the 3i Atlas signal that Lena had posted to a preprint server, something caught his attention. The harmonic ratios looked familiar, not from astronomy, but from his own work. He pulled up his CMB datasets and began comparing. The match was not exact, but it was close. Too close to ignore. Certain intervals in the 3i Atlas signal mirrored the acoustic oscillations preserved in the cosmic microwave background, the sound waves that rippled through the early universe's plasma, leaving imprints in the temperature map of the cosmos. These oscillations were fundamental, a record of how matter and energy interacted in the first moments of existence. He contacted Yuki immediately. "I think your signal is referencing the CMB," he said, his voice tight with excitement. "Look at these ratios. They correspond to the baryon acoustic oscillation peaks. The signal is encoding the same mathematical relationships that shaped the early universe." Yuki pulled up the data he had sent, overlaying it with the resonant pattern. The correlation was undeniable. The signal's harmonics aligned with the primordial sound of creation, the deepest, oldest patterns in the cosmos. "How is this possible?" she whispered. Harold had a theory. The CMB is everywhere. It fills all of space. Any observer anywhere in the universe would detect it. If you wanted to create a universal reference frame, something that any intelligence could recognize, regardless of when or where they existed, you'd use the CMB. It's the one signal that's truly cosmic, truly timeless. Lena, joining the call, took this further. So the 3i Atlas signal is not just a message. It's a message that connects to the origin of everything. It's saying, we're part of the same universe. We emerge from the same initial conditions. We're connected through deep time. The team absorbed this in silence. If the signal referenced the CMB, then its origins, or at least its conceptual framework, predated human civilization, predated Earth, predated the Sun. The patterns it encoded were older than stars, woven into the structure of space when the universe was a fraction of its current age. Could 3i Atlas have carried information that old? Could an object drifting through interstellar space preserve knowledge from the deep past? Or was the signal not carried by 3i Atlas, but created by it? A resonance triggered by the object's passage, awakening something latent in the fabric of space itself. "It's like a tuning fork," Amara said slowly. 3i Atlas passed through, vibrated at the right frequency, and resonated with structures that were already there. The signal isn't new, it's ancient, it's always been part of the universe, waiting for the right conditions to become audible. Yuki thought about the universe as a musical instrument, its strings stretched across billions of light years, waiting to be plucked. 3i Atlas had plucked one of those strings, and the sound that emerged was older than memory. She felt a profound sense of humility. They were not discovering something alien, they were discovering something primordial, something woven into the cosmos from the beginning. If this was communication, it began before we existed. Chapter 21. The Mirror Principle. The hypothesis coalesced over weeks of intense collaboration, drawing together insights from neuroscience, cosmology, signal processing, and philosophy. They called it the mirror principle, the idea that the 3i Atlas signal was not a one-way transmission, but a reflective interface. A mirror shows you yourself. It does not create an image, it returns one, shaped by your own presence. The mirror principle suggested that the signal operated similarly. It did not contain a fixed message, but adapted to reveal patterns back to the observer, patterns shaped by the observer's own conceptual framework. Lena formalized the hypothesis in a draft paper, carefully worded to avoid overreach. We propose that the 3i Atlas signal exhibits properties consistent with reflective or adaptive information encoding. Rather than conveying a predetermined message, the signal's structure appears to resonate with the interpretive framework applied by the observer, revealing patterns that correspond to the observer's own cognitive and technological capabilities. This behavior is not consistent with classical broadcast communication, but may represent a novel form of interactivity embedded in the electromagnetic substrate of space. It was a radical claim, but it was testable. They designed experiments to probe the signal's responsiveness. They varied observation parameters, frequency ranges, integration times, directional antennas, and monitored how the signal changed. They applied different analytical methods, Fourier transforms, wavelet decompositions, machine learning algorithms, and tracked the structures each method revealed. The results were consistent with the mirror principle. The signal did not change randomly. It changed coherently, in ways that reflected the observational approach. When they searched for mathematical constants, the signal highlighted mathematical constants. When they searched for musical structure, the signal emphasized harmonic relationships. When they searched for spatial patterns, the signal's visualization became more geometric. It was as if the signal was not passive, but participatory, as if observation was not measurement, but conversation. Dr. Amina Jabari, a philosopher of science who had joined the team to help frame the implications, offered an interpretation. "What you're describing is a phenomenological interface," she said during a seminar. In phenomenology, the idea is that reality is not objective and independent of observers, but co-constituted through the interaction between mind and world. The signal, if your hypothesis is correct, embodies this principle. It's not an object with fixed properties, it's a process that unfolds through observation. But that violates the principle of objectivity, Marcus countered. Science is based on the idea that reality exists independently of whether we observe it. Maybe, Amina replied, or maybe that's a useful approximation that breaks down at certain scales or in certain contexts. Quantum mechanics already tells us that observation affects reality at the microscopic level. What if the same is true at the cosmic level? What if the universe itself is participatory, requiring observers to bring certain aspects of reality into existence? The debate was profound, touching on questions that had occupied philosophers for centuries. What is reality? What is observation? What is the relationship between mind and matter? The 3-Atlas signal did not answer these questions, but it forced them into the foreground, demanding that the team confront the assumptions underlying their entire scientific worldview. Yuki, reflecting on this late one night, wrote in her journal, "We thought we were studying an object, but perhaps we've been studying a relationship. The signal is not separate from us. It's an interface between us and the universe, a way for the cosmos to reflect our own structure back at us. We are not decoding a message, we are recognizing ourselves in the mirror." She thought about how every great discovery in science had ultimately been a discovery about ourselves. Copernicus taught us we're not the center. Darwin taught us we're not separate from nature. Hubble taught us we're not alone in the universe. The 3-Atlas signal, if understood correctly, might teach us the deepest lesson yet. We're not separate from reality. We are part of its creation. It was not telling us something, it was showing us ourselves. Chapter 22. The Hidden Constant. 3 months into the renewed observation campaign, Samuel Chen made a discovery that would change everything. He had been analyzing the signal's temporal structure, mapping how its harmonic intervals shifted over time. Most of the variations seemed random at first, fluctuations without obvious pattern. But Samuel had a hunch. He decided to compare the signal's time-based modulations against known astronomical rhythms, the rotation periods of planets, the orbital frequencies of moons, the oscillation modes of stars. Nothing matched, until he tried Earth. The signal contained a recurring modulation with a period of 86 Dals 164 seconds, the exact length of a sidereal day, Earth's rotation period relative to distant stars. He ran the analysis 3 times, checking for errors, for coincidences, for any prosaic explanation. The correlation held. The 3-Atlas signal was resonating with Earth's rotation. When he presented this to the team, the reaction was immediate and visceral. This was no longer abstract. This was personal. The signal was not just reflecting human cognition or referencing cosmic history. It was acknowledging a specific world, their world. "This can't be coincidence," Amara said, her voice barely above a whisper. Earth's rotational period is not a universal constant. It's specific to us, local. The only way the signal could contain this rhythm is if it's responding to Earth specifically. Lena pulled up a visualization of the signal over time, highlighting the 8664-second modulation. It was there, subtle but persistent, woven through the entire structure like a hidden message. "It's like a handshake," she said slowly. "A way of saying, I see you. I know where you are. You're part of this." Marcus struggled to find an alternative explanation. Gravitational interaction? Could Earth's mass be affecting the signal somehow, creating a periodic variation? "No," Samuel replied. "The signal is electromagnetic, propagating at the speed of light. Earth's gravity couldn't modulate it in this way, not across interstellar distances." Yuki felt a chill run through her. For months they had debated whether the signal was natural or artificial, random or intentional, meaningful or empty. But this was unambiguous. The signal knew Earth existed. It knew how fast Earth spun. It had encoded that knowledge into its structure. How? Raj proposed a mechanism. What if the signal really is interactive? What if it samples the local environment wherever it's being observed and incorporates those characteristics into its structure? It's not that someone programmed Earth's rotation into the signal. It's that the signal learned Earth's rotation by interacting with the observational equipment located on Earth. It was a compelling idea, and it aligned with the mirror principle. The signal was not broadcasting. It was dialoguing. It was adapting itself to include information about the observer's context, their location, their temporal rhythms, their physical constants. But that implied a level of sophistication, of responsiveness, that strained belief. "You're saying the signal is intelligent," Marcus said flatly. "No," Raj replied carefully. "I'm saying the signal behaves as if it has properties we associate with intelligence: adaptability, responsiveness, contextual awareness. But those properties might not require consciousness. They might be emergent features of a complex electromagnetic system interacting with its environment." The team sat with this, each processing it in their own way. Yuki thought about the countless signals humanity had sent into space, radio broadcasts and spacecraft trajectories, and the faint electromagnetic whispers of a technological civilization. Most of those signals carried no deliberate message. They were side effects, artifacts of daily life. And yet, someone listening from afar might decode patterns within them: the rhythm of television schedules, the periodicity of power grids, the modulations of communication networks. Maybe the signal was the same, not a deliberate message, but a fossil, a trace, an imprint left by something vast and incomprehensible as it moved through space. We were, in some way, included. Chapter 23. The Atlas Reawakens. The observation came from the Hubble Space Telescope during a long-exposure imaging campaign of the outer solar system. An astronomer reviewing archival images noticed a faint point of light in a region of sky that had been empty months before. Cross-referencing the position against known objects, she found no match. But when she plotted the trajectory backward in time, it aligned with 3i Atlas's predicted path. The object had reappeared, not close, not bright, but visible again, reflecting sunlight in a way it should not have been able to, given its distance. The news reached Yuki within hours. "It's impossible," Marcus said when he saw the data. 3i Atlas is beyond Neptune by now, too far to reflect enough sunlight for visual detection. The albedo would have to be extraordinary. "It always was extraordinary," Yuki reminded him quietly. They requested additional observations. The James Webb Space Telescope, with its infrared sensitivity, was redirected to capture the object's heat signature. Ground-based adaptive optics systems locked onto the coordinates. Within a week, the confirmations came. 3i Atlas was there, and it was bright. Not just bright, it was glowing, emitting more light than could be explained by reflected sunlight alone. Infrared analysis showed elevated temperatures, as if something internal had activated, warming the object from within. The team scrambled to understand. What mechanism could cause an inert rocky object to suddenly become luminous? Radioactive decay, residual heat from stellar formation, impact events. None of the models fit. Then Amara noticed the timing. The object's reillumination had begun precisely when the signal had returned. when the 3:14-day pulse had reappeared in the radio data. The correlation was exact. "They're connected," she said, "the object and the signal. They're not separate phenomena, they're two aspects of the same thing." Lena expanded on this. What if 3i Atlas is not just a rock? What if it's a transducer, a device, natural or artificial, that converts one form of energy into another? It passes through space, absorbs energy from the stellar environment, stores it, and then releases it as electromagnetic radiation. The signal isn't coming from empty space. It's coming from the object itself, mediated through the interstellar medium. But the signal appeared after 3 Atlas was already too distant to detect, Marcus objected. How could it generate a signal from there? Maybe distance is irrelevant, Raj suggested. If the signal is embedded in the structure of space, propagating through resonances in the interstellar medium, then the object doesn't need to be nearby. It just needs to have initiated the process. Like ringing a bell and then walking away and the sound continues. The conversation spiraled into theoretical territory, but the data remained stubborn. 3 Atlas was active again, and its activity was synchronized with the signal. High-resolution imaging revealed something else. The object's surface, previously smooth and featureless, now showed faint linear patterns, grooves or channels that caught the light at certain angles, geometric, regular, unmistakably artificial. Or were they? Crystalline structures could form naturally under extreme conditions. Erosion could carve patterns into rock. But the symmetry, the precision, the alignment with the object's rotational axis, all suggested design. Samuel, who had been analyzing the new optical data, spoke carefully. If this is an artifact, if 3i Atlas is something made rather than born, then we're looking at technology on a scale we've never encountered. Not a spacecraft, not a probe, something else. A beacon, maybe, or a seed. Something meant to endure, to persist, to interact with the universe over timescales we can't fathom. Yuki looked at the image on her screen, a tiny distant point of light shining against the backdrop of stars. It had come from beyond, passed through, and was now leaving again. But it had left marks, patterns, messages perhaps, or memories, traces of an existence that exceeded human, categories. She thought about the word atlas, a map, a guide, a carrier of knowledge. Maybe that was what 3i Atlas was. Not an answer, but a question. Not a destination, but a signpost. The messenger had turned its face once more. Chapter 24. When Silence Spoke. It took Yuki weeks to fully understand what they had been hearing. The signal, she realized, was not defined by the frequencies it contained. It was defined by the spaces between them, the silences. Music is not just notes. It is the rests, the pauses, the empty beats where sound does not happen. Without silence, music is noise, a continuous, undifferentiated hum. Silence gives structure. It creates rhythm, phrasing, meaning. The 3i Atlas signal had silence woven through it. Gaps in transmission, moments where the harmonic intervals stopped and the background returned. At first, the team had dismissed these gaps as noise, as dropouts in the data, as moments when the signal was simply absent. But Yuki began to suspect otherwise. She analyzed the gaps themselves, treating them as data. She mapped their duration, their spacing, their distribution across the signal's history. And she found patterns. The silences were not random, they were structured. They formed their own rhythm, a counterpoint to the audible frequencies, and when she mapped them temporally, they corresponded to significant moments in the observation campaign. Moments when instruments were recalibrated, when observation windows shifted, when the team changed their analytical approach. It was as if the signal was pausing deliberately, creating space for the observers to reflect, to adjust, to bring their own interpretation to bear. Elaine, the composer, immediately understood. It's call and response, she said, a fundamental structure in music and communication. One voice speaks, then pauses. The other voice responds. The silence is not empty. It's an invitation. Lena expanded this into a broader framework. What if the signal's entire purpose is to teach us to listen differently? Not just to sound, but to silence. Not just to presence, but to absence. We've been trained to see information as positive, as data points, as signals, as things that exist. But information can also be negative. The absence of a signal can be as meaningful as its presence. Yuki thought about the philosophy of negative space in art, where the empty areas of a painting are as important as the filled ones, the spaces between words, where meaning gestates, the silence between heartbeats, where life is measured. The signal had not been speaking continuously, it had been breathing, and in its exhalations, in its silences, it had given the observers space to participate, to co-create, to bring their own meanings into existence. She thought back to the signal's collapse, the 2 months when it had vanished completely. At the time, it had felt like an ending, like loss. But perhaps it had been intentional, a pause, a rest in the cosmic composition, allowing humanity time to process, to reflect, to prepare for the signal's return. Silence, she realized, was not the absence of communication, it was its foundation. Dr. Amina Jabari, the philosopher, summarized it beautifully during a seminar. In Western thought, we tend to privilege presence over absence, being over non-being, sound over silence. But other traditions, Taoism, Buddhism, indigenous cosmologies, recognize that emptiness is not nothing. It is potential. It is the space where things can emerge. The signal seems to embody this principle. It is teaching us that communication is not about filling the void, but about honoring it. Yuki recorded the signal's silences, isolating them from the frequencies, creating an audio file that contained only the gaps. When she played it back, she heard something unexpected. A rhythm, a pulse, a pattern that felt almost like language, even though it contained no sound. It was the sound of waiting, of patience, of space held open for another voice to enter. She understood now. The signal was not trying to tell them something. It was not even trying to show them something. It was trying to create space for them to speak. We had learned to listen differently. Chapter 25. The Cosmic Listener. The realization that silence carried meaning transformed how humanity approached the search for cosmic signals. New observational protocols were developed, frameworks that treated absence as a form of data. Radio telescopes were reprogrammed to map not just where signals appeared, but where they conspicuously did not appear. Voids in the electromagnetic spectrum that might indicate intentional quietness, regions of space that were too silent to be natural. Dr. Yuki Tanaka, now recognized as a leading figure in the emerging field of negative space astronomy, proposed a radical redesign of SETI initiatives. Instead of listening only for transmissions, humanity should listen for patterns of silence, for the structured absence of noise, for the gaps between stars where something might be deliberately withholding its presence. "We've been shouting into the void for decades," she said during a keynote address at the International Astronomical Union. "Broadcasting our presence, beaming signals toward distant stars hoping someone will hear. But what if the most profound form of communication is listening? What if the act of sustained, patient attention is itself a signal, a way of saying, we are here, we are aware, we are part of the cosmos?" The idea resonated. New instruments were funded, designed not just to detect electromagnetic radiation, but to analyze its absence. The Silent Sky Array, a distributed network of radio telescopes spanning 6 continents, was built specifically to map the quietest regions of the universe, to find patterns in the darkness. And they found them. Subtle, yes. Difficult to distinguish from natural voids, from the simple absence of active sources, but statistically significant. There were regions of space where the background noise was lower than it should be, where the expected hum of cosmic radiation was muted, as if something was absorbing it, or shielding it, or simply choosing not to emit. Were these natural? Almost certainly most of them. Dust clouds, gas voids, regions where the interstellar medium was unusually sparse. But some, a few, resisted easy explanation. They were too symmetrical, too well defined, too persistent across observation epochs. The scientific community debated their significance. Skeptics called it confirmation bias, the human tendency to find patterns in randomness. Believers called it the first evidence of intentional quietness, of civilizations or processes that communicated through absence rather than presence. Lena Kowalski proposed a philosophical shift. Maybe we've been thinking about communication wrong. We assume it's about transmission, about sending information from one place to another, But what if communication is about creating conditions for understanding, about shaping the informational environment so that meaning can emerge? Silence is not the opposite of communication. It's a form of communication, a way of creating space, of inviting attention, of allowing the other to speak. Yuki thought about this often. She thought about the 3-eye atlas signal, which had taught them to listen not just to frequencies, but to the pauses between them. She thought about how the signal had adapted, responded, mirrored the observers back to themselves. And she thought about humanity's place in the cosmos. For centuries, humans had imagined themselves as speakers, as broadcasters, as the ones who would initiate contact. But perhaps the universe did not need more voices. Perhaps it needed more listeners. Perhaps the most profound contribution humanity could make was not to announce its presence, but to pay attention, to hold space, to witness the cosmos with humility and openness. She looked up at the night sky from her apartment window, the familiar constellations sharp against the dark. Somewhere out there, 3 Atlas continued its journey, glowing faintly, its signal still pulsing through the interstellar medium. And somewhere else, other signals existed, or other silences, structured and intentional, waiting for someone to notice them. Humanity was learning to listen, not just with instruments, but with a new awareness, a recognition that observation was participation, that attention was a form of communication, that to truly hear the universe, one must first be willing to sit in silence. To listen is to exist. Chapter 26. Echoes Within Us. Dr. Ishani Kapoor continued her work at the intersection of neuroscience and cosmology, pursuing a hypothesis that had been growing in her mind since she first visualized the 3 Atlas signal as a neural network. If the signal resembled a thought, then perhaps thoughts resembled signals. She began a research program, comparing the electromagnetic signatures of neural activity, brainwaves captured by EEG and MEG, with the structure of cosmic signals. The scale was vastly different, of course. Brainwaves operate at frequencies of a few hertz to a few hundred hertz, over distances of centimeters. Cosmic signals operate at megahertz to gigahertz, over distances of light years. But the patterns were strikingly similar. Both exhibited harmonic structures. Both showed oscillations that synchronized and desynchronized in complex rhythms. Both contained nested frequencies, where slower rhythms modulated faster ones, creating hierarchical temporal architecture. Both were adaptive, changing in response to context and input. Ishani published her findings in a paper titled The Fractal Brain: Cosmic Resonances in Neural Dynamics. She argued that the similarities were not coincidental, but reflected deep principles of how information is organized in nature. The universe, she wrote, may be structured according to the same principles at all scales, from the firing of neurons to the resonance of interstellar plasma. Information seeks to organize itself into patterns that are efficient, adaptive, and self-similar. Consciousness, in this view, is not unique to biological brains. It is a potential property of any sufficiently complex interconnected system. The paper sparked intense debate. Some called it a breakthrough, a unification of neuroscience and cosmology that opened new avenues of research. Others called it speculative, a poetic analogy mistaken for science. But Ishani had data. She showed that the harmonic ratios present in the 3-eye atlas signal matched, within measurement error, the ratios found in the default mode network of the human brain. The pattern of neural activity that occurs during rest, during introspection, during moments of self-reflection. We are resonating with the cosmos, she said during a public lecture. Literally, the frequencies that organize our thoughts are the same frequencies that organize the universe. When we observe the 3-way atlas signal, we are not looking at something alien. We are looking at a mirror of our own cognitive architecture, writ large across space and time. Yuki attended the lecture remotely, watching from her office. She felt a deep sense of recognition, of pieces falling into place. The signal had always felt familiar, even when it was strange. Perhaps that was why. It was not foreign. It was an echo of the same processes that created consciousness in the first place, the self-organizing, resonant patterns that emerge when matter and energy interact in complex ways. She thought about the phrase, as above, so below, an ancient Hermetic principle suggesting that the macrocosm and microcosm reflect one another. Modern science had largely dismissed such ideas as mysticism. but perhaps they contained a truth that physics was only now rediscovering. The brain is made of atoms, governed by quantum mechanics and thermodynamics. Those same forces shape stars, galaxies, the interstellar medium. Why should the patterns be different? Why should consciousness be confined to neurons when the principles that generate it might be universal? Amara, who had been following Ishani's work, put it simply, maybe we've been asking the wrong question all along. Not, is there intelligence in the universe, but is the universe itself intelligent? Not as a conscious entity, but as a system that naturally generates consciousness wherever the conditions are right. Yuki wrote in her journal that night, "We are not separate from the cosmos. We are its way of knowing itself. The neurons in my brain, firing as I write these words, are part of the same electromagnetic tapestry that carries the through atlas signal across the void. We are echoes within echoes, patterns within patterns, a universe folding back on itself in an act of self-recognition. Perhaps we are the signal returning home." Chapter 27. The Observer's Burden. 5 years after the initial detection of the three-eye atlas signal, Yuki Tanaka sat in a quiet cafe in Kyoto, watching the rain trace patterns on the window. She had become famous in the way scientists sometimes do, invited to conferences, interviewed for documentaries, consulted by governments and research institutions. The signal had changed her life in tangible ways: career advancement, recognition, opportunity. But it had also changed her in ways harder to articulate. She no longer looked at the sky the same way. Every star, every patch of darkness, every faint flicker of light carried the possibility of meaning. She found herself listening not just with instruments, but with intuition, with a kind of attentiveness that bordered on meditation. The universe had spoken to her, in its subtle way, and she could not unhear it. But there was a cost. Observation, she had learned, was not a neutral act. It was a relationship. And relationships change both parties. The scientists studying the signal had been transformed by it. Their assumptions challenged, their worldviews expanded, their sense of self and cosmos intertwined in new ways. This was the observer's burden, to be changed by what you see. Lena Kowalski had articulated it in a recent paper. Every measurement is an interaction, every observation is an entanglement. When we study the universe, we do not stand outside it, cataloguing its properties like passive witnesses. We participate in its unfolding. Our questions shape the answers we receive. Our attention brings certain aspects of reality into focus while allowing others to recede. We are not discovering the universe. We are co-creating it. Yuki thought about the signal's adaptive behavior, how it had mirrored the observer's own frameworks back at them. It had not been passive. It had responded, adapted, evolved. And in doing so, it had forced the observers to evolve as well, to question their assumptions, to expand their categories, to consider possibilities they had dismissed. She thought about the broader implications. If observation was participatory, then humanity's presence in the cosmos was not inconsequential. Every telescope pointed at the sky, every radio antenna listening to the void, every spacecraft sent into the dark, all were acts of participation, ways of shaping the universe through attention and intention. This was both empowering and humbling. Empowering because it meant humans were not separate from the cosmos, but integral to it. Their curiosity, their creativity, their drive to understand, these were not accidents, but expressions of the universe's own drive towards self-knowledge. Humbling because it meant responsibility. If observation shaped reality, then what observers chose to look at mattered. What questions they asked mattered. The frameworks they brought to their investigations mattered. Yuki had become acutely aware of this. She chose her research directions carefully now, thinking not just about what she wanted to discover, but about what kind of universe she wanted to help bring into being. Did she want a universe where intelligence was rare and humanity alone? Or a universe where intelligence was abundant, woven through space in forms subtle and diverse? Did she want a universe governed solely by mechanistic laws, indifferent to observers? Or a universe that was responsive, participatory, alive in some fundamental sense? Her choices, she knew, would influence what she found. Not because she was falsifying data, but because attention was creative. By looking for certain patterns, she would make them more likely to appear. By asking certain questions, she would open certain pathways in reality. This was the observer's burden, and also the observer's gift. She finished her tea, paid, and stepped out into the rain. Above, hidden by clouds, the cosmos continued its slow dance. Stars being born, galaxies colliding, signals propagating through the dark. And somewhere, 3 Atlas drifted onward, carrying its mysteries into the deep. The universe had not changed. We had. Chapter 28. A Light That Waits. 7 years after the signal's first detection, the transmission changed one final time. It did not grow stronger. It did not reveal new structures. It simply settled. The harmonic interval stabilized. The 3.14-day pulse continued, steady and patient. The signal no longer adapted or evolved. It became, in a sense, complete. The team, now dispersed across different institutions but still connected through the invisible web of collaboration, noticed this simultaneously. Yuki, Marcus, Lena, Amara, Samuel, Raj, Ishani, they convened one last time, in a virtual meeting that felt both routine and momentous. It's reached an equilibrium, Amara observed. Whatever process was generating the signal has stabilized. It's not changing anymore. Or it's finished, Lena suggested quietly. Maybe the signal was always building towards something, and now it's arrived. They analyzed the stable pattern exhaustively, searching for any final revelation, any hidden message they might have missed. They found nothing new. The mathematics were the same, the harmonics unchanged, the embedded constants, the fractal geometry, the resonance with Earth's rotation, all present, all accounted for, all exactly as they had been. And yet the signal felt different. It felt final. It's a farewell, Samuel said after a long silence. Not in words, but in structure. The signal is saying, this is what I am, this is all I am, take from it what you will. Yuki felt a pang of something like grief. For years the signal had been a living thing, evolving and responding, a presence in her life as constant as the sunrise. And now it was complete, finished. It would continue broadcasting, of course, until distance and dispersion rendered it undetectable. But it would not surprise them again. It would not reveal anything new. The exploration was over. Marcus, ever pragmatic, framed it differently. Maybe it's not an ending. Maybe it's a beginning. The signal has given us everything it can. Now it's up to us to interpret it, to integrate it, to decide what it means for how we understand the universe. Or maybe, Raj offered, it's just waiting for the next observer, the next civilization, the next consciousness to tune in and reflect themselves back. Maybe we were never the only audience. The idea settled over them. The signal was not for humanity alone. It was a lighthouse, beaming into the dark, patient and eternal. Whoever found it, whenever they found it, would see themselves reflected in its structure. It was a universal mirror, a cosmic Rorschach test, designed to persist across eons. Lena pulled up the latest visualization of the orbital mandala, the fractal structure embedded in the signal. It rotated slowly on her screen, pulsing with quiet light. "It's beautiful," she said softly. "Whatever it is, whatever it means, it's beautiful. And maybe that's enough. Maybe the universe doesn't owe us explanations. Maybe it's enough that it creates beauty and invites us to witness it." Yuki thought about the years of work, the late nights, the debates, the moments of frustration and revelation. She thought about how the signal had changed her, expanded her understanding of what was possible, taught her to listen not just to sound but to silence, not just to data but to the spaces between. She thought about 3i Atlas, that distant enigmatic object still drifting through the dark, still glowing faintly, still carrying its mysteries into the infinite. And she realized the signal had never been about understanding. It had been about relationship, about connection, about the simple, profound act of one part of the universe acknowledging another. "Thank you," she whispered, not to the team, but to the signal itself, to the cosmos, to the vast, incomprehensible presence that had reached across the void and touched them, briefly, with its light. The team logged off, one by one, returning to their separate lives. The signal continued, patient and eternal. Perhaps messages do not end. They fade. Chapter 29. The Last Frequency. It was a graduate student at the University of Tromsø, Norway, who made the final observation. Kari Anderson had been studying Earth's magnetosphere, the invisible magnetic field that shields the planet from solar wind and cosmic radiation. She was analysing data from ground-based magnetometers and satellite instruments, mapping the flow of charged particles through the polar regions where they create the aurora borealis, the northern lights. In her data, she noticed an anomaly, a faint periodic fluctuation in the magnetosphere's resonance frequency, synchronized with a rhythm she recognized from her background reading, the 3.14-day pulse of the 3I Atlas signal. She cross-referenced the timing carefully, accounting for light travel time and signal propagation delays. The correlation was exact. The 3I Atlas signal in its final act was interacting with Earth's magnetosphere. Kari contacted Yuki immediately, sending her the data with a subject line that read simply, "You need to see this." Yuki opened the files and felt her breath catch. The magnetospheric resonance showed modulation patterns that matched the signal's harmonic structure. It was as if the signal, after years of propagating through space, had finally reached Earth not just as electromagnetic radiation, but as a physical interaction with the planet's protective field. And that interaction was creating auroras. Kari had observed the northern lights on the night the correlation was strongest, and she had recorded video. Yuki watched it now. Curtains of green and violet light rippling across the Arctic sky, pulsing in waves that seemed to follow a rhythm, slow, steady, harmonic. The 314-day pulse rendered in light. Yuki felt tears sting her eyes. The signal had not just been a radio transmission or a thermal trace or a fractal pattern in data. It had become visible, tangible, something anyone could witness without instruments or expertise, just by looking up. She shared the discovery with the team. Within days, amateur astronomers and aurora chasers around the world began reporting similar observations. The northern and southern lights were behaving unusually, showing periodic intensifications that correlated with the signal's rhythm. Photographers captured stunning images, auroral arcs that seemed to pulse in time with an invisible heartbeat, green and red and violet waves that danced across the sky in patterns that felt almost intentional. Social media exploded with speculation. Was it natural? Was it a sign? Was 3 Atlas, in its final farewell, painting the sky? Scientists were more cautious, but even they could not deny the beauty and strangeness of it. The signal, through some complex interaction with Earth's magnetosphere, was manifesting as light, ephemeral, fleeting, but undeniably real. Lena Kowalski wrote a short piece for a popular science magazine. The universe speaks in many languages: radio waves, infrared heat, gravitational ripples, and now light. The 3I Atlas signal, which has journeyed across the void for years, has reached Earth in the most human way possible, as something we can see with our own eyes. The auroras have always been there, of course, a natural phenomenon driven by solar wind, but now they carry an additional resonance, a faint echo of something that came from far beyond. In a sense, the sky is shimmering with a message we may never fully understand, but which we can nevertheless witness and appreciate. Yuki travelled to Tromsø to see the auroras herself. She stood on a frozen hill outside the city, beneath a sky ablaze with shifting light, and felt the profound smallness and connectedness of being human. The signal had travelled across light years. It had been detected, analysed, debated, visualised, and now in its final form it had become art. A dance of light and magnetism, visible and ephemeral, a gift from the cosmos to anyone willing to look up. The sky shimmered one last time. Chapter 30. The Signal. After the silence. 10 years after the first detection, Yuki stood on a stage at the International Conference on Astrobiology, addressing an audience of thousands. She was older now, her hair threaded with grey, her eyes carrying the weight of a decade spent navigating the intersection of science and mystery. The 3I Atlas signal had defined her career, but it had also defined her life, shaping how she thought, how she saw the world, how she understood her place in the cosmos. She began her talk with a question. What is a signal? She let the question hang in the air. We think of signals as transmissions, information sent from one place to another, encoded in electromagnetic waves or sound or light. A signal has a sender and a receiver, a message and a meaning. But what if we've been thinking about this too narrowly? She advanced her slides, showing images, waveforms, auroral displays, the orbital mandala, the fractal structure of neural networks, the cosmic microwave background. The 3i Atlas signal, she continued, never fit neatly into our categories. It was not a broadcast in the traditional sense. It did not convey a single, fixed message. Instead, it was adaptive, reflective, participatory. It responded to how we observed it, mirroring our own structures back at us. And in doing so, it taught us something profound. That signals are not just about information. They are about relationship. She paused, letting her words settle. The universe is full of signals. Starlight reaching us from distant galaxies, gravitational waves from colliding black holes, the faint hum of the cosmic microwave background. Each of these carries information, yes, but more than that, they are invitations. Invitations to pay attention, to connect, to participate in the unfolding story of the cosmos. She clicked to a new slide, a photograph of Earth from space, small and blue against the black. For most of human history, we thought we were alone. We imagined the universe as a vast empty stage on which we played out our small dramas. But the 3i Atlas signal, whatever its origin, reminded us that we are not separate. We are part of a larger whole. Every observation we make, every question we ask, every moment of attention we offer, these are not passive acts. They are creative. They shape reality. They participate in the cosmos's ongoing process of self-discovery. She could see faces in the audience. Scientists, students, dreamers, all listening intently. The signal taught us to listen differently, not just to presence but to absence, not just to sound but to silence. It taught us that meaning is not fixed but emergent, that the universe does not owe us answers but offers us patterns and invites us to find our own meanings within them. She thought about the years of work, the debates, the discoveries, the moments of awe and frustration. She thought about 3i Atlas, still drifting somewhere in the dark, its light fading, its signal dispersing into the noise of deep space. We may never know what 3i Atlas was, we may never decode its signal in the way we hoped, but perhaps that was never the point. Perhaps the signal was not trying to tell us something, perhaps it was trying to show us how to listen, how to sit with uncertainty, how to embrace the mystery without needing to resolve it. She advanced to her final slide, a single sentence in white text on a black background. The silence was always speaking. The universe, she said softly, has been communicating with us since the moment we first looked up at the stars. Not through words or symbols, but through patterns and rhythms and resonances that connect us to everything that is. The 3i Atlas signal was not an anomaly. It was a reminder that we are part of this cosmic conversation, that our attention matters, that the act of listening is itself a form of participation. She smiled, a quiet, peaceful expression. Maybe the universe never sent a message. Maybe it only asked if we were listening. The audience was silent, and in that silence, something profound resonated. The night sky has not changed. The stars still burn with the same ancient light. The galaxies still spiral through their slow gravitational dances. The cosmic microwave background still hums, a whisper from the beginning of time. The universe, in its vast indifference, continues as it always has. But we have changed. Humanity, in its brief existence, has learned to listen. We have built instruments that extend our senses across the electromagnetic spectrum, capturing signals from the farthest reaches of space and time. We have learned to translate those signals into images, into data, into stories about where we came from and where we might be going. And in the process, we have become part of the story ourselves. The 3i Atlas signal, that faint, strange resonance from an object that passed through our solar system and vanished into the dark, did not answer the great questions of existence. It did not prove the existence of alien intelligence. It did not reveal the secrets of the cosmos, but it did something more profound. It reminded us that we are not separate from the universe, but woven into its fabric. That observation is not passive, but participatory. That meaning is not found, but created through the relationship between observer and observed. We look up at the stars, and the stars look back. Not with eyes, not with intention, but with light. photons that have traveled across unimaginable distances to reach our retinas, carrying information about the past, about the present, about the structure of space and time itself. And when we receive that light, we complete the circuit. We become part of the universe's way of knowing itself. Perhaps this is what consciousness is, the universe paying attention to itself through countless eyes, countless minds, countless moments of awareness scattered across space and time, each observer a node in a vast distributed network of perception, contributing their unique perspective to the whole. The 3-eye atlas signal is still out there, fading into the cosmic background, its patterns dissolving into noise. Future civilizations, if they exist, may detect it and wonder what it was. They may decode it differently, finding meanings we never imagined. Or perhaps the signal will fade entirely, lost to entropy and distance, a fleeting whisper that existed for a moment and then was gone. It does not matter. What matters is that we listened, that we paid attention, that we allowed ourselves to be changed by the encounter. The universe is full of signals waiting to be heard, full of silences waiting to be honored, full of mysteries waiting not to be solved but to be experienced. We are part of it. We always have been. And somewhere, in the vast dark between stars, an object drifts onward, a mirror, a messenger, a mystery. Silent now, but forever echoing in the minds of those who heard its call. Perhaps the universe never sent a message. Perhaps it only asked if we were listening.